So this is the result
No, this is the curve.
for what we
Glycerin.
did.
Yeah, this is the curve for glycerin. So if you go to overview, this is glycerin, this is butane triol, and this is supposed to be sitting on top of each other because it's supposed to be the same. Which is like, it's pretty tight. It's like plus or minus 10, maybe 12. Yeah. And then this is monos, so like see, this is very linear.
Mono is like
Sorry, monoolein. So
Mono-
the monoglycerides.
okay, cool. And this is diglyceride.
No, this is butane triol, so this is the internal standard for the glycerin. This is monoolein. This is tricapran, which is the one for the rest of them. And then this is diglyceride, so diolein. So
The rest of them.
this is the internal standard for the monoglycerides, diglycerides, and triglycerides.
Oh,
That's what I meant.
okay.
And then this is the triglycerides. So yeah, see, all of these are linear except for glycerin, and that kind of bothers me. So I'm gonna mess with it for a second and try to get this a little bit more linear, because for some reason number 3 is being problematic. So let's figure out why. Level 3, replace.
What's level 3?
That's the level 3 standard. So that kind of helped, just like a little bit. I mean, it's 0.99, so it's like not. Let's just try it. Okay, I'm gonna save the method.
What did you delete?
I didn't delete anything. I just deleted. I deleted this the sample or the. No, do not save the changes to death signal. So see, if I were to click save, then it would have deleted the integrations for all of those, because I didn't want it to update for the other ones, because for some reason it's like it didn't save my integrations from the last time. So I'm just gonna try to roll with this.
Okay.
So I did that. I think this should hopefully be good. I analyze it this way.
Okay.
And if need be, I can just delete standard 3
Okay.
and
So,
try that.
so what is it at right now with standard 3 in there?
0.99.
Okay.
All the other ones are like 5.9s.
Okay.
So they're very linear.
Okay.
But well, we're just going to try to analyze this.
Okay. So have you already injected stuff in there then?
Yeah, it's
okay.
already been run.
Okay, great.
It already ran.
It's good to see you, by the way.
Yeah,
I'm
good
glad
to
you
see
did
you
as
too.
well.
Thank you. I appreciate it. It's funny that he sent Mason City biodiesel
Why?
because it's special.
Okay.
Because they use a higher amount of corn oil,
Mm-hmm.
so you normally wouldn't see this peak.
Okay.
This is actually ethyl ester.
Okay.
Most other biodiesel does not have ethyl ester in it.
Right.
But because they have such a high amount of corn oil, then it produces large ethyl ester peaks.
Really? Okay.
So that's what that is.
So it'll be interesting to see what happens, because for the 111, the freshman lab,
Yeah.
so they're actually doing biodiesel. So they're making it, purifying it, sending it through an ion exchange,
Nice.
and then distilling the methanol, the glycerin, and then we're going to come in here and test it. And so I gave them the choice of doing canola, soybean, or someone picked corn oil. So it'll be interesting to see what happens with the properties. So, but,
Yeah, the only thing about using corn oil is that it's kind of fun in cold weather, but
Mhm.
then so is soybeans. So
Right.
it'll be like,
yeah. So okay.
yeah. That's cool. I'm glad that that project actually worked out.
Yeah, it's really cool.
Good.
It's been really good so far.
Good. I'm very happy to hear that. I remember that right before I left. I was like, I hope that works out. Okay, come on. peak summing, and this gives you monos, monopalmitin, dis, and tris. So I'm going to zoom back in. Okay, so this actually looks a little weird, but let's try to figure that out. So it's saying that this one is mono-olein. So I guess this is monostearin, and that's monopalmitin. So I'm gonna put monopalmitin starting at 14.5 minutes and then ending at 14.7. After I do this, you're not going to need to update this. Hopefully. 14.68. Okay. And then monoglycerides will start here, so like 15.9 or maybe 0.8. I can type. To 16.45. So this is just important to check every time that you do it because it could shift. So I overdid it, for instance, so I'm going to update that to 15.9 because it's going to add everything that's in this window.
How do you know that's monoglyceride?
So when I did the standards, that's where it told me mono-olein is, and it overlapped with this exactly. So I know that there's a doublet here, and then there's a big peak and a little peak. So it's pattern recognition. So I think Dr. Williams is pulling up an example chromatogram because I think they have one at the back of the method.
Yeah, so I was looking for where the method was.
And then like diglycerides, I'm going to do this whole thing. So 20.1 to 20.7. So that's good. And then tris would be 22.5 to 23 maybe. So tris is going to be like, if you see two dis, you should see two tris. So that should be really the only thing out there.
So here it says, if you look here, so monoglyceride, so peak identification, right? Monoglyceride consists of 4 overlapping peaks with relative retention times of 0.76 and 0.83 to 0.86 with respect to the internal standard tricapran.
Yeah.
So if you know where tricapran is, then if you go to 0.76, 0.83 to 0.86 of that, that's where the mono-olein is going to sit. So this table here basically says, if my tricapran is my standard, if I set that as 1, then if I go 0.76 and 0.83 to 0.86 of that time, that'll tell me where the mono-olein is. The diglyceride is going to be 1.05 to 1.09 of that retention time, and the triglyceride is 1.16 to 1.31. So in the standard, it has an example chromatogram, right? So here is your glycerol, here's your butane triol, here is your for tricapran. I think this is your tricapran, is I think this one here. So these are where your monoglycerides are going to sit. That's where your diglycerides are going to sit, and that's where your triglycerides are going to sit. All right. So generally in the 14-minute range, right, is where the monoglycerides are. Is that where you're at? 14 something.
Well,
14.5
there's
to
3.
Yeah,
So
but the 14.5 somewhere in that window.
14 to like 17.
And then diglycerides are in the right. So here's 14.5, 15, 16, 17. So that window there is where the monoglycerides would be. And then the diglycerides are going to be somewhere around the 20 range, and the triglycerides are going to be somewhere around the 23 range. So
you have to set this equals to 1 first.
well, you're saying if I use that as kind of a starting point, right?
Oh.
So if I use my if I use my tricapran time, so the retention time of the tricapran is 19.234.
Mm-hmm.
So if I use that as like as a standard point, right? Say, so 19.2334 times 0.78
Oh.
is about 15 minutes.
Okay, cool.
Right, and then
Got it.
19.234 times 0.86 is about 16 and a half. So my window is going to be from 14.5-ish to like 16 point something-ish or 17, and that's going to be my mono-oleans. Now they say, okay, if my tricapran is 19.234, for my diglycerides, it's like 1.05 to 1.09. So I would take that times 1.05, and I get 20.19. So my diglycerides are going to be in the 20 range. So I go from like 20 or 19 something to like 21 something. And then same thing I would do with the triglycerides, 19.234 times, this says here about 1.15, maybe.
6.
So somewhere around 22. And that's what you're seeing for that retention time. That's where triolean was.
Okay.
So they give you a range, a window that you're going to look for monoglycerides, diglycerides, and triglycerides, because it's not just going to be one peak. It's going to be a bunch of little peaks depending upon what your free fatty acid, what your composition of the oil that you start off with, right?
So if you want, another thing that you could do is you can make like a reference standard. So you can like buy glycerides and then just dilute it in whatever, maybe pyridine, and then you can shoot that. And then if it overlaps with that directly, then you know. But that's also assuming that your free fatty acid composition, she just said, it's going to be the same. Which is like when you're doing used cooking oil, that's not going to happen.
Right. So typically we just say, based on the ASTM method, wherever our tricapran standard comes out to be, we know mono-oleans are going to be short of that, diglycerides are going to be just past that, triglycerides are going to be a couple minutes past that.
So we have good news.
Yeah?
It passed. The units are all off. So we're going to have to figure the math out. But this is all like giving me something that's at least like near. So like free glycerin is like 0.005 and this says 6.
Right, but you see what I'm saying? There's like it's
Yeah.
like there's like a multiplier of 100 in there, and I don't know where that's
Well, so
coming
I know how to fix that.
Okay.
And that was my fault.
from. Okay.
I just put the number. I just shot the numbers in because I wanted to like not waste people's time.
Okay.
Because I could tell that they were starting to like get lazy.
All right.
So I just need to figure out. Well, because what I did was I took the numbers from this and I just put them in face value.
Right.
And then the numbers the weights that I put in, those need to correspond properly.
Right.
So like you either put it as milligrams or as grams.
Okay.
And so those all compound to
Okay.
do this.
And I could never get that to work right, but if I took the areas and put them into, said, okay, I'm gonna take those areas, I'm gonna plug them into an Excel spreadsheet where I can just put in the volume, the weights,
Yeah.
it would calculate fine. So yeah, if you can figure out
Yeah.
what are the right units to put in for this formula, that would be great. Because the units that we were putting in never seemed to match up. So,
Okay, I can mess with that. But
Okay.
it,
Great.
it
So
works.
that's awesome. So then they had, so monoglycerides was
0.242. So if that's 0.006, then
Right.
that's basically 0.2.
Right.
So
and then diglycerides is 0.01.
is 0.01. So if you 3 over 0.013.
Right. And then triglycerides is 0.
Zero.
Right.
So
okay.
yeah, we didn't see
Great.
anything. So yeah, it
Okay. Good.
it's
That's
working.
awesome.
It's just the units are off, which is not whatever. I just gotta fix that.
Okay. So what happens if you take out the third point for the free glycerin in here? Do we get closer? Because this was 0.005 and we would be at 0.006.
Yeah, which is really that's
pretty
really
close.
tight.
Right. Okay.
That's like
Great.
yeah. I mean, I can mess with it. I just like at this point I want to have something.
Yeah. No. That's great. I'm glad it's yes. That's awesome. Okay.
I'm glad I could be helpful. my 4 years here paid off. Oh, that's funny. Okay, so yeah, method. Actually, wait. Let me close this out first. Actually, no, it's on standby. We're fine. Okay, so I'm gonna get. So this is done.
Right.
So I'm gonna go to method and run control.
So say that again. So it will be in the video. So die has 2 humps, and then you have to like integrate as one.
Yeah, because it's a doublet.
And try has 2 single.
Yeah, tries has 2 single humps.
Okay, cool.
Yeah. Alright, so this part, hopefully you're never gonna have to do. But, okay, edit entire method. So we're gonna go through all of this. This whole part doesn't really matter.
So what we did here is like calibration, right?
No, this was data analysis. Oh, she's locked.
So what do you do now? Adjusting what you put in?
Yeah. This should, I'm looking for, there. So, one option is changing these, because I put these in at face value.
Mm-hmm.
So this
What's face value?
whatever was in here,
Okay.
I think that's where it was.
Yeah.
So this is, so we want this to come out as ppm. So this is in ppm. So yeah, this is in ppm, micrograms per milliliter.
Right. Which is what you're, and that's in milligrams per microliter.
Well, so this amount is, you can set it to whatever it
Okay.
is. It doesn't actually like do any calculations based
Okay.
off of this, but this is already in ppm.
Right.
So if that's the case,
So what happens, Max, is, and I don't know if you explained this last time, but when you get a biodiesel calibration kit, it will come with a certificate of composition, and it will tell you the exact concentration of each of the components in each of the vials that you get, right? And that's what you enter into the GC, so that when you do your calibration curve, it knows exactly how to translate area into composition, because you're using this calculation. Now, we used to have a problem before, because we would take these standards and we would dilute them a lot, so we would have to change the concentration. But you didn't dilute them; you did it based on the standard, right?
yeah, I didn't.
Based on the method, right? So doing
I did
like,
the whole thing.
right. So we would always take part of the vial, and so you'd have to say, okay, it's 50 micrograms per milliliter, but we only injected like a tenth of that sample into the.
Oh, okay. I think this is what the issue was. I think what we need to do moving forward is put this in as milligrams,
Okay.
or put this in as grams, not milligrams,
Okay.
because then all these numbers would be divided by 100.
Okay. So
Right.
what you put in there was
Milligrams.
Milligrams.
Or I guess no, that would be 1,000, right? Because 1,000 milligrams is 1 gram.
Right.
So if
So
we do
those are
6,
milligrams. You would divide those by 1,000 to get
Yeah,
grams.
which makes sense because that's 0.006.
Right.
So that's what we did wrong.
Okay.
This needs to be in grams,
Okay.
and then that'll fix it.
Okay.
'Cause, yeah,
All right. So if we do that, if you do that now, and then it should adjust, right?
yeah. So 6. Well, this was the sequence table before. So I think what I would have to do.
But if you adjust the sequence table now, will it?
No.
Okay.
I would have to reprocess it. So I could try that. Let me try that.
Okay. Good.
Let's try that. Okay, so if you go here, this has the sample info. So there should be.
So your sample amount there would be 0.001 for heptane.
The sample here would be. Oh no, heptane doesn't matter. You can leave heptane as 1 because it doesn't calculate anything.
Okay, 95.07.
So that would be 0.095.
0.09507.
Yeah. Okay, so let me remember how to do this. Edit sequence parameters. No. There's a way to do this.
How do you?
Now I need to reprocess this. Use current method. Okay, now I think you press this button. No, that's not what I want. There we go. That's what I want.
Okay.
That's how you reprocess it.
And then now go to the report, right?
It's gonna take a second. I didn't update the internal standard amount.
Well, but that internal standard amount you've put in, but you're using it from the method, not from the data, not from the sample.
Oh, that's true. That's true.
So it's still going to show us 1,000.
Yeah, you're right.
So you've changed that already?
Yeah, I changed it. Okay, so let's see what that looks like. Okay, so if I go to mine, go to integration, just to make that a little bit. Okay, report, print report. Yeah, 1 and
okay.
8. Yep. Yeah.
Because it's supposed to be 0.005, and
Yep.
then
Or point. Yep.
0.005,
Yep.
and then 0.242,
So 0.2. Yep.
and then 0.001 and 0.
Yep. That worked.
Yep, awesome.
All right. Great job.
So what we put in as in the method won't matter. It's because what we put in the sample, 1,000, 8,000, whatever.
Yeah.
It's fine. It'll still use the multiplier,
It'll use it from what's in the method.
and then you still put the sample in milligrams.
Yeah. Now you leave it as milligrams.
Yep.
Correct.
Oh, we did right now.
Well, so all of this stuff you don't need to do. What we did just before this, you will need to do.
To analyze the result.
Yeah, to analyze the results, yes. But now it should just spit out what you need.
But what we did, what did you do here?
So here's what I mean. What I did here was I went and I checked all of the peaks, and then I made sure that they were all right, and then any of the ones that I needed to redraw, like this one, I redrew. I saved it. Then I went here, made sure that all of my peaks were overlapping properly, and that it was doing it all. And then I went to report, print report.
Overlapping?
Yeah, if I go to Diolean, I want the peaks to be in here.
Okay.
You see?
But in the future, do we have to identify the area ourselves first, or we can just click it, the blue will come out?
You should be able to click it. Now, it might shift over time, so you might need to. But these windows are so wide, probably not.
Okay.
But the important part is to check every time. Just don't assume. Just check.
Okay.
Yeah. I was a little bit jumbled today, so let me just start over. So here's what you do. When you go in, you want to go through, and you want to zoom in to the chromatogram.
Mm-hmm.
And then you want to make sure that all your peaks are right. So if you go and you zoom in like I taught you, small but wide, after a while you will understand, you will just remember the retention times. So glycerin's 4.7. So you're gonna go here and you're gonna be all right, does that look good? Yeah. That looks like you got all the areas.
Okay.
So what is this now?
So I was just kind of going, so we're done.
Okay.
Everything's good.
Okay.
I was just kind of going over you're going to go through and you're going to be okay, I know glycerin's 4.7. So I'm going to look at this peak and I'm going to be all right, does this look good? Does this have all the area represented that I want? Yes. Okay, this is butane trial. Does this look like it has everything? Because every once in a while it might look like that. The line might be from here to here. And you're okay, that's not accurate. So then you'll redraw it. And then you'll do that for all your peaks that you're looking at. So then you'll have glycerin, butane trial, over here will be the monos, over here will be the dyes, and then if you'll have tris, so tris will be over here.
So when they're injecting a new sample,
Yeah.
right? Do you know how to set up the method and everything else to do a new sample
That's
injection?
what we did last time.
Okay.
Okay. So basically, all they would have to do is put in the milligrams of whatever sample is that they've loaded into the vial, right? And you know how to do all of the additions of the internal standard added to it and the
He actually did that last time, so he personally knows how to do it.
Okay, so yeah, so basically now, as soon as you have a sample of your hemp oil, dried and you know washed and dried and run through the ion exchange column, that you can take a sample of that, mix it up in the vial like you would, put it in there and run it, and see what your free glycerin and total glycerin looks like, and it has to pass the specifications based on, you know.
Well, that's the only thing about this is that you have to manually calculate total.
Okay.
Because that's a calculation.
Yeah, but it gives you the calculation, right?
In the method.
In the
yes.
method, yeah.
Yeah.
So here, right, the limit is for free glycerin is 0.02 max, and then for monodiene there's a limit on there if or total glycerin is 0.24, right? We're not really there's a limit on monos, but not for the grade of biodiesel that we're looking at. So in here. It tells you here. So total triglyceride, that's reproducibility. So calculation of total glycerin is going to be total glycerin is free glycerin plus bound glycerin, and so you basically take the sum of 2.2591 times the mass percent of monoglyceride, 0.1488 times the mass percent of diglyceride, and 0.1044 times the mass percent of triglyceride. Add all of those up, and then add the free glycerin to that, and then that gives you your total glycerin.
Okay.
Okay, and then it tells you here the specification is in. It's gonna be in this. It's in the main method. It is 51, which I don't think is in here. But in the main biodiesel method, main ASTM standard for biodiesel, it says what the limit is for free glycerin, total glycerin, and then monoglycerides if you want to have a specific grade of biodiesel. Okay.
This is a different method?
This is the method for free and total glycerin.
Oh, okay.
There's an ASTM specification for biodiesel.
Oh,
that
okay.
says the free and total glycerin has to meet this specification.
Uh-huh.
Okay.
Cool. Well, thank you so much.
No problem.
Awesome.
Hence why I'm wearing my shirt.
That's right.